is 3.9 related rates. What is this? Well, let's suppose the volume of a sphere, 4 pi thirds r cubed. Volume sphere. As you see here, volume is involved, radius is involved. This is an equation that connects two variables, volume and radius. Now, if I differentiate both sides, assume that V and R are, I have to get rid of this. I need another marker. 1 second. So assuming that, and I'll explain in which situations in a moment. So assuming that V and R are changing. In other words, they depend on time or are functions of time. In other words, V is a function of time and R is a different function of time. So assume that these are changing. When I differentiate the left-hand side and I differentiate the right-hand side, I will get a new equation, dV over dt equals 4 pi r squared dr over dt. I'm differentiating with respect to time. So this is another equation that does not relate the volume to the radius, but relates or connects the rate of change of volume to the rate of change of the radius. And this is what we mean by related rates. They are in a relationship. Which relationship? This one. So the variables, or the functions if you want, are related by this relationship. Their rates of change are related by another equation. In which situation this may happen? Here's an example. Let's suppose I have a balloon. Here's the balloon. And it's flat, it has no air in it. And let's suppose I start blowing air into the balloon. So it looks like this, then it looks like this, and so on and so forth. So the volume and the radius, while I pump air in this balloon, or tire, or whatever you want, the radius changes, the volume and the radius are changing, are increasing. And the relations between their rates of change is this, with respect to time. So this is what we mean by related rates. We start with an equation that relates the functions, the volume, function of time, and the radius, function of time. And from here, we determine an equation, a relationship between the rates of change of these two. And we say that they are related. They are related because they are in the same equation. Every time we have variables that are in the same equation, they are related. What's the relationship? V equals 4 pi over 3 r cubed. What is the relationship between the two rates? The rate of change of volume equals 4 pi r squared times the rate of change of the radius. And this is an application in many situations. So we are ready to start practicing this. You choose first and I choose second, or vice versa, it doesn't matter. You decide. So find the indicated rate. Ta, 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 ta. All these are exactly to what we just practiced. Here, later in word problems, we will see something a little bit more different. But let's practice 1 through 20. Who chooses first?
Number 6.
Yes, let's start with number 6. Perfect. Let's take a look at 6. 6, okay. And this is on page 364. And we have y equals 4x squared. They want us to find dx over dt when x equals 5. And dy over dt equals -3. Perfect. Very good pick. Oh, good warm-up. Good. So this is the question. They are giving us this equation. Like in my simple equation, two functions. They are both functions of time. They are related. This is it. This is a function of time. How do I know? Because I'm told dy over dt is -3. So this is a function. How do I know that x is a function of time? Because I'm asked to find dx over dt. So x is a function of time. Otherwise, this does not exist. So exactly like in my simple example, these are two functions of time. I am asked to find the relationship between their rates of change. Okay, fine. So I will differentiate both sides. Dy over dt, 8x times the inner function prime. So the process of determining from the functions the relationship between their rates is done. Now I'm asked to find dx over dt, so this is my variable. I will divide both sides by 8x. dx over dt equals dy over dt. You cannot separate these two, although you know that they have separate meanings, over 8x. The rest is a piece of cake, because I'm asked to find this dx over dt when x is 5 and when dy over dt equals -3. No problem at all. I will continue and just write dy over dt, I'm told is -3 at the top. 8 times 5, and this is it. So from the given equation that relates the two functions to each other, I was able to find another equation that relates their derivatives to each other. Then I was asked to find dx over dt. I did. And then I was asked to plug in these numbers in what I have, which I did. So then the answer is -3 over 40. Any questions? Okay. Let's practice some more. Anyone, anything? From 1 through 20.
Can we do 17?
Yes, with pleasure. 17 it is. In 17, we're given y equals p squared times q. Find dq over dt. Okay, when P equals 15, Q equals 40, dP over dt equals 55, and dy over dt equals 54,750. Okay, perfect. So this is the question. We are given a relationship, an equation that relates three functions. Y is a function of t, P is a function of t, Q is a function of t. So all these three are functions of t, meaning three different functions. So I have to be very mindful of that. Good, I'm ready to differentiate. I differentiate the left-hand side, I differentiate the right-hand side. The left-hand side is dy over dt. The right-hand side is the product rule. So 2p dp over dt times q plus p squared times q prime. But I cannot write q prime. I have to write dq over dt. Okay, again, what am I after? Okay, this is my variable. Not this, not this, nothing, just this. I move this term to the other side and divide by p squared. So dq over dt equals this dy over dt minus 2pq dp over dt over p squared. Let's take a moment and look at this. Please let me know if there is any doubt. Any doubt.
How did you get the differentiated of both y and, yeah, that one?
Okay. So this is a function times another function prime. Function times another function. So I have to use the product rule. I differentiate the first function times the second one, plus I copy the first function times the second one prime. So when I differentiate p squared, I differentiate the function squared. 2 times p to 2 minus 1 times the inner function prime, dp over dt, times the second function. Now plus the first function times the second function prime. Is that better?
Yes.
Now, this are known. This is my variable. How do I know? From here. I am asked to evaluate this for the given information. So I move this to the other side and it changes sign. And then I divided the whole thing, dy over dt minus 2pq dp over dt, everything over p squared. And now I'm going to enter everything to determine this value. So dq over dt equals dy over dt 54750 minus 2p 30 times 40 times dp over dt times 55 over p squared, 15 squared to 25. Okay, I hope my, yes, it's awake and doing very well. Calculator. Okay. Good. So parentheses for the top. 54750 minus, again it was 30 times 40, 30 times 40, yes, 1200, correct, multiplied by dp over dt, which was 55, correct. Close the parenthesis and divide by 225, which is 15 squared. Okay, negative 50. So dp dp over dt equals negative 50. Any questions on this problem? Any questions?
Can we try another one like that?
Oh, absolutely. My pleasure. You choose. Oh, you can choose. Now you can.
Can we do 20?
Very good. Let's do 20. Perfect. So let's copy it. In 20, we have a squared equals b squared plus c squared. So, or are greater than or equal to 0. Okay. Find dc over dt when b is 7, c is 24, db over dt equals 3, and dA over dt equals 0.84. Perfect. Good. So the indication is very clear that A, B, and C are all functions of t. dc over dt tells me that c is a function of t. dB over dt tells me that b is a function of t. And dA over dt tells me that a is a function of t. So this is the relationship among three functions. I am able to now find the relationship among the related rates, among the rates of these three functions. When I differentiate a squared, I get 2a dA over dt. When I differentiate b squared, I get 2b dB over dt. And the same thing, 2c dc over dt. Because I can simplify, I divide both sides by 2. I shouldn't be doing that. I should just write it on the side and then write it again. So the variable that we are after is dc over dt, which is this. I'm going to move this term here and divide everything by c. So dc over dt is a dA over dt minus b dB over dt, and everything divided by c. Now I will plug all that in to determine the final value. Okay, A. Okay, we do have B, we do have C, but we don't have A. No worries. A squared equals B squared plus C squared. But I have that this is 49, and I have that this is 24 squared. They are trying to trick us. They're not giving us A, but we can find it. They gave us B and C. Once I have B and C, I can determine A. So I'll have to calculate and take the square root. So I have 49 and plus 224 squared. I get this. I take the square root, and we know that this is 220, this 25, but We know that, 25. So then A is 25. Because they're telling us I did not take plus or minus, apply plus or minus, because they're already telling us that. So back to our final answer, 25. dA over dt is 0.84 minus B is given to us as 7, dB over dt is 3, and everything divided by C, which is 24. Careful how you enter it in the graphing calculator, please. So we have parentheses, 25 multiplied by 0.84, and then minus 21, 3 times 7, and divide everything by 24. And we get fine. dC over dt equals 0. Okay. Very good. How do we feel about this?